Hi, my name is Basir. In this video, I will be solving questions from Chapter 9, Differentiation from Intermediate First Year Mathematics, Math 1B, Telangana State and Andhra Pradesh syllabus. Now, I will be solving pretty much close to 7 questions from previous year question papers. If you stay with me till the end of the video, I am sure you will understand differentiation and you will master it in no time. And also, for those who have not yet subscribed to the channel, please make sure you subscribe to the channel, like and share it so that those videos benefit your friends and acquaintances too. And as a matter of fact, I will be uploading videos on a daily basis almost every single day, and not just videos of mathematics. I will upload videos of physics and chemistry as well. So it's going to be a kind of a win-win situation for you and for me. Let's sit down and solve 7 questions that have appeared in previous year question papers. Hi, my name is Basir. In this video, I will be solving questions from previous year question papers for intermediate first year mathematics, Math 1B, from the chapter 9, which is differentiation. Now, these questions were asked in section A, which carries 2 marks. Let's go through these questions one by one. If you haven't watched my previous video, please make sure you watch the previous video in which I talked about the formulae of differentiation. I talked about the product rule, the quotient rule and the chain rule. Let's start solving the first question here. Now the first question, it says, find the derivative of the function f of x is equal to 5 sine x plus e power x log x. Now this question was asked in Telangana State May 2019 question paper. Let me first write the function that is given to us. It says f of x is equal to 5 sine x plus e power x log x, and we are supposed to find the derivative of the function. How are we going to find the derivative? By differentiating it. I'm going to differentiate both sides with respect to x. So let's write here, differentiating with respect to x on both sides. So on both sides, I'm going to differentiate with respect to x. For differentiating with respect to x, you write something known as d by dx with respect to x. So I wrote a x here. Now I'm differentiating the left hand side, which is f of x, and then I am differentiating the right hand side, which is 5 sine x plus e power x log x. Now since I have 2 terms here, 5 sine x is my first term and then e power x log x is my second term, I am going to distribute the differentiation to both the terms. I'm going to distribute the differentiation to the first term. I'll keep a plus sign, and then I'll differentiate and I'll distribute the differentiation to the second term, which is e power x log x. Now d by dx of f of x would be f dash of x. I'm going to distribute d by dx to the first term, which is 5 sine x, and I'm going to distribute the differentiation, which is d by dx, to the second term, which is e power x log x. Now, what should I do here? How do I differentiate 5 sine x? Let me take the constant out of the differential. So let's do it this way. F dash of x is going to be, I'm going to take 5 out of the differential d by dx, and I'm now left with only sine x. How am I going to differentiate e power x log x? Now you have to understand here, e power x is an exponential function in x, and then log x is a logarithmic function in x. So I have 2 functions here. Since I have 2 functions here in x, I'm going to use the product rule, and I suppose I already talked about the product rule, so I'm going to do it directly here. How am I going to differentiate this? I'm going to keep aside the first function, which is the exponential function. So I'm going to keep aside e power x, and I'm going to differentiate log x. The next time, I'm going to keep aside log x, and I'm going to differentiate e power x. Let me take you through this thing once again. 5 was a constant, I took it outside, and I'm now left with only sine x. Since I have 2 functions here in x, and I have an invisible multiplication operator here, so they are kind of a product. So now we have to use the product rule. How do you use the product rule? Take out the first function, differentiate the second one, keep a plus sign, take out the second function, differentiate the first one. Now what happens when we do this? 5 d by dx of sine x is nothing but cos x. From one of my previous videos, you can actually download the PDF document in which you will find the formulae, and those formulae are obviously going to come handy when we start solving these questions. E power x, d by dx of log x is 1 by x, and then the plus sign I wrote it as it is. Let me write log x as it is. D by dx of e power x is e power x itself. Now you can keep it this way, or else since the second term has an e power x, the third term also has an e power x, I can take e power x common. Let's do it this way, 5 cos x plus, I'm going to take e power x common from the second term and the third term. So if I remove e power x from the second term, I'm left with 1 by x, and if I remove e power x from the third term, I'm left with log x. So that's how we found out the derivative of f of x, which was 5 sin x plus e power x cos x. Let's move on to the next question now. The second question, it says x is equal to e power sine hy, and we are supposed to find out dy by dx. There are actually quite a few ways of doing this. Let me first write what is given to us. It says x is equal to e power sine hy, and we are supposed to find out dy by dx, which means I have to differentiate this with respect to x. How are we going to differentiate this? You can actually start differentiating this directly, or you can apply log on both sides. Now I don't really see the need of applying log on both sides, because you can actually differentiate it directly. If you want, perhaps let's do this. I will do this, I'll find the derivative of this using both ways. Let's say this is method 1, which I'm going to use here. I'm going to differentiate it directly with respect to x, and the second time I'm going to apply log on both sides, and then I'll find out the derivative. Now let's write here differentiating with respect to, I can just use the abbreviation WRT, which means with respect to x on both sides. Let me differentiate the left hand side, which is x, and then let me differentiate the right hand side, which is e power sine hy. Now how are you going to differentiate this? X, when you differentiate with respect to x, you get 1 d by dx of e power sine hy. I don't have a formula to find out the differential of e power sine hy. So you are going to consider sine hy as x. Let's consider sine hy as x in our mind. Now d by dx of e power x is nothing but e power x itself. But then sine hy is not x in reality. So you have to differentiate this as well as per the chain rule. So let's differentiate sine hy. Sine hy is a hyperbolic function. Now e power sine hy into d by dx of sine hy is cos hy. And then we have to differentiate this y here. As per the chain rule, you have to differentiate y here. So this is how you end up getting the value of dy by dx. What would be dy by dx? Since these two things are multiplying on the right hand side, I'm going to divide them on the left hand side. So e power sine hy into cos hy, that gives me dy by dx. So that's how you end up finding dy by dx. Now you can keep this as it is, or there is perhaps one other thing that you can do here. E power sine hy, since e power sine hy is x, in place of e power sine hy, I can write x. So let me replace this thing with x. So dy by dx is 1 by x cos hy. So this is one way of differentiating this. Let me differentiate this by using one more method. Let me teach you how to differentiate this by applying log on both sides. Let me name this as method 2. What is given to us? It's given that x is e power sine hy. X is e power sine hy, I'm going to differentiate this time by applying log on both sides. Applying log on both sides. So when I apply log here, I'm going to apply log on the left hand side. Similarly, I'm going to apply log on the right hand side. Now you know that, I believe this is something that you already know from your previous grade. Log a power m is nothing but m log a. So actually the power that you see here, it comes in front of the logarithm. So that is something that we are going to use here. The power that you see here, sine hy, we are going to bring it forward. So sine hy, and then you end up having log e here. Now what is log e? Log e is nothing but 1. Log e is nothing but 1. So let us write 1 there. Now that we have simplified this thing to an extent, we can start differentiating this. Differentiating with respect to x on both sides. Now I'm differentiating the left hand side with respect to x. The left hand side is log x, and I'm differentiating the right hand side, which is sine hy, with respect to x. D by dx of log x is 1 by x. D by dx of sine hy is cos hy, and as per the chain rule, you have to differentiate y as well. So you have to differentiate y. So now, since cos hy is multiplying on the right hand side, it would be dividing on the left hand side. So it comes in the denominator here. And again, we ended up getting the same answer. Dy by dx is 1 by x cos hy. Dy by dx is 1 by x cos hy. So there are two ways of doing it. Let's move on to the next question here. The next question, let me try this one first. It says, if f of x is equal to 1 plus x square plus so on till x power 100, then find f dash of 1. Let me first write what is given to us. It says f of x is 1 plus x square plus so on till x power 100, and we are supposed to find out f dash of 1. Let us first find out f dash of x. How are you going to find f dash of x? By differentiating with respect to x on both sides. So you are going to differentiate with respect to x on the left hand side, and I'm going to differentiate with respect to x the right hand side as well. Now what happens when I do that? D by dx of f of x is nothing but f dash of x. And how are you going to differentiate this thing? The differential, you can actually start distributing the differential to all the terms. I'm going to distribute the differential d by dx to all the terms here. So let's do it. D by dx, I'm distributing it to 1, and also d by dx, I'm going to distribute it to x also, and then d by dx I distribute it to x square also, so on, and then d by dx I distribute it to x power 100 also. Now what happens? F dash of x is equal to 1 is a constant. If you differentiate the constant, you obviously end up getting 0. X, when you differentiate it with x, you get 1. D by dx of x square. How are you going to differentiate this? D by dx of x square. D by dx of x square, we can actually make use of this thing. D by dx of x power n is nothing but n into x to the power of n minus 1. So the power, it comes in the front, and then 1 gets subtracted from the power. So this is what it really is. The power 2, it comes in the front, and then from the power 2, you have to subtract 1. 2 minus 1 is 1. So you can write 1, or you can just leave it. So on till d by dx of x power 100. This is again in the form of d by dx of x power n. So the power 100, it comes in the front, and then you have to subtract 1 from the power. 100 minus 1, that gives us 99. So we got f dash of x as 0 plus 1 is nothing but 1 itself. So I'm going to get rid of 0 here, and I am now left with something like this. I was supposed to find out how much is f dash of 1. See, they asked us to find f dash of 1. How do you get f dash of 1? In place of x, you have to write 1. We'll do the same thing on the right hand side as well. In place of x, let me write 1. Again here, in place of x, let me write 1. What happens when I do that? This is 1, 2 into 1 is 2, so on. 1 power 99, 1 if you multiply 99 times, you obviously end up getting 1 itself, because 1 into 1 is 1, 1 into 1 is 1. If you multiply 199 times, you obviously end up getting 1 itself. 100 into 1, that gives you 100. How are we going to find out the sum of these numbers? Now, if you have a close look at these numbers, you will realize that these are natural numbers. Natural numbers, they obviously start from 1. So 1 plus 2 plus 3 plus 4, so on till 100. Those are the first 100 natural numbers. And we have a pretty simple formula to find out sum of n natural numbers. To find out sum of n natural numbers, you can use the formula n into n plus 1 by 2. And since I am supposed to find out sum of 100 natural numbers, in place of n, I'm going to write 100. Why? Here n stands for the number of terms. I see 100 terms here, so in place of n, I'm going to write 100. In place of n, I'm going to write 100. So what am I getting now? F dash of 1 is 100 into 100 plus 1 is 101 by 2 as it is. 2 into 5 is 10, 0 as it is. So F dash of 1 is going to be 101 into 5 into 50. 101 into 50 is 5050. So that's our answer here. We were given the function f of x as 1 plus x square plus so on till x power 100, and we were supposed to find out f dash of 1, and we found out the value of f dash of 1. Let us now move on to the next question here. Let's do this question here. If f of x is 2x square plus 3x minus 5, then prove that f dash of 0 plus 3 f dash of minus 1 is 0. How are we going to do this? This is again pretty simple. Let me first write what is given to us. It says f of x is 2x square plus 3x minus 5. F of x is 2x square plus 3x minus 5. I'm supposed to prove f dash of 0 plus 3 times f dash of minus 1 is 0. Since I need to get f dash, I have to differentiate this, because when you differentiate f of x, it becomes f dash of x. So let's differentiate with respect to x on both sides. So I'm differentiating the left hand side f of x with respect to x, and I'm differentiating the right hand side, which is this thing, with respect to x. D by dx of f of x is nothing but f dash of x. And how are you going to differentiate this thing? You can distribute the differential to the first term, to the second term, and to the third term. So let's do it. So differential d by dx, I distribute it to the first term, and then I distribute the differential to the second term, and then I distribute the differential to the third term. Now what happens? Since 2 is a constant here, I'm going to remove the differential. I'm going to take it out of the differential, and since 3 is also a constant here, I'm going to remove it out of the differential. I'm going to keep this 5, which is a constant, as it is, because I don't have any other variable here. So let's keep it there at itself. So f dash of x is going to be 2. I'm going to take it out of the differential d by dx, and then I'm left with only x square. Here 3, I'm going to take it out of the differential. I'm left with only x here, and since this is all by itself, let me keep 5 as it is inside the differential. Now what happens? This 2, I'm going to write it as it is. D by dx of x square. D by dx of x square is nothing but 2x. How? We are going to make use of this. D by dx of x power n. So x power 2 is in the same format, d by dx of x power n. What are we supposed to do? We are supposed to bring forward the power and then subtract 1 from the power. 2 minus 1 is 1. D by dx of x is nothing but 1 itself, because x, when you differentiate it with x, you end up getting 1. When you differentiate the constant term, you end up getting 0. So f dash of x is 2 into 2, 4, 4x. 3 into 1 is 3, minus 0, I can just get rid of minus 0. What am I supposed to find out? I am supposed to prove f dash of 0 plus 3 times f dash of minus 1 is 0. Let me first find out f dash of 0. How do you get f dash of 0? In place of x, you have to write a 0. So on the right hand side also, in place of x, I'm going to write 0. F dash of 0 is going to be 4 into 0 is 0 plus 3 as it is. So f dash of 0 is 0 plus 3, which is 3. Now let me also find out f dash of minus 1, and then we will substitute the value of f dash of 0 and f dash of minus 1 here, and then we'll prove that this thing becomes 0. Let me find out f dash of minus 1. How are we going to get the value of f dash of minus 1? In place of x, let us write minus 1. So in place of x, let me write minus 1 here. What happens when I do that? 4 into minus 1 is nothing but minus 4. F dash of minus 1 is minus 4 plus 1 is minus 4 plus 3 is minus 1. Now let us find out f dash of 0 plus 3 f dash of minus 1. So let us consider the left hand side. F dash of 0 plus 3 f dash of minus 1. In place of f dash of 0, I'm going to write 3, because the value of f dash of 0 is 3, and then this 3, let us write it as it is. In place of f dash of minus 1, I'm going to write minus 1. This 3 is as it is, plus into minus is minus, 3 into 1 is 3, 3 minus 3 is 0. So we were supposed to prove that f dash of 0 plus 3 f dash of minus 1 is 0, and we already proved it. Let's move on to the next question. The next question, it says, find the derivative of the function tan inverse of log x. Now this question was asked in AP March 2019 question paper. Let me first write what is given to us here. I have a function tan inverse of log x. Let us take this function as some f of x. So f of x is given as tan inverse of log x, and we are supposed to find the derivative of this function. So I'm going to differentiate with respect to x on both sides. So I'm going to differentiate with respect to x on the left hand side, and then I'm going to differentiate with respect to x the right hand side as well. Now d by dx of f of x is nothing but f dash of x. D by dx of tan inverse log x. I don't have a formula for finding the differential of tan inverse log x, but then I have a formula for finding differential of tan inverse x. And what is that? D by dx of tan inverse x is 1 by 1 plus x square. D by dx of tan inverse x is 1 by 1 plus x square. So I'm going to assume log x as x. So I am going to assume that this is x, this complete thing, this log x is x. So now d by dx of tan inverse x is nothing but 1 by 1 plus x square, and I'm assuming log x is x here. But then in reality log x is not x, so we have to differentiate this thing also as per the chain rule. So what happens? F dash of x is equal to 1 by 1 plus log x whole square. D by dx of log x. We know that d by dx of log x is 1 by x. So in place of d by dx of log x, I can write 1 by x. So f dash of x is 1 by x into 1 plus log x whole square. We were supposed to differentiate the function tan inverse of log x, and we successfully differentiated it. Let's move on to the next question here. I have another question here which says f of x is log of tan e power x, and I'm supposed to find out f dash of x. How do you get f dash of x? If you differentiate f of x, you end up getting f dash of x. So I have to differentiate the function. So let's first begin by writing what is given to us. It says f of x is equal to log of tan e power x, and we are supposed to find out what is f dash of x. Let us differentiate with respect to x on both sides. So I'm going to differentiate with respect to x, the left hand side, and I'm going to differentiate with respect to x, the right hand side as well. Now d by dx of f of x is nothing but f dash of x. D by dx of log of tan e power x. I don't have a formula to find out the derivative of log of tan e power x. But then I have a formula to find out the derivative of log x. D by dx of log x is 1 by x. So I'm going to assume this complete thing as x. Let's assume that this is x. Let us assume this thing in our mind itself. You can actually take tan e power x as some u. But then I don't want to do it that way. I want to keep things as simple as possible. So let's make use of chain rule here instead of coming up with new variables here. Let us consider this complete thing as x in our mind. D by dx of log x, I know that d by dx of log x is 1 by x. This complete thing, I assume that this is x. But then in reality this is not x. So as per the chain rule, you have to differentiate this thing, tan e power x. So f dash of x is going to be 1 by tan e power x into d by dx of tan e power x. What is d by dx of tan e power x? I don't have a formula to find out the derivative of tan e power x, but then I have a formula to find out the derivative of tan x. D by dx of tan x is secant square x. So I'm going to assume this as x in my mind. So I'm going to assume that this is x. D by dx of tan x is nothing but secant square x. But in reality this is not x. So as per the chain rule, I'm supposed to differentiate this now. Now what happens? F dash of x is 1 by tan e power x secant square e power x. D by dx of e power x is nothing but e power x itself. Now you can actually keep it this way, or else if you want you can simplify this thing a little further here. Let me actually simplify this thing a little further for you. F dash of x is going to be 1 by tan e power x. 1 by tan e power x, I can write it as sine e power x by cos e power x, because you know for a fact that tan is nothing but sine by cos. Secant square e power x. Secant square e power x, I can write it as 1 by cos square e power x, because secant is reciprocal of cos, right? So secant can be written as 1 by cos. This e power x, let me write it as it is. Now you would see for yourself, one of the cos e power x from here, and then one of the cos e power x from here, they cancel out, and you are left with e power x in the numerator. 1 into 1 is 1, 1 into e power x is e power x, and then you are left with these two things in the denominator, sine e power x, cos e power x. That's about it. Now let's move on to the next question here. Question number 7. Question number 7, let's do this. If f of x is equal to cos of log of cot x, then find f dash of x. Let me first write the function that is given to us. It says f of x is equal to cos log cot x. Now we are supposed to find out f dash of x, which means we are supposed to differentiate this function. If we differentiate f of x, we end up getting f dash of x. So let us differentiate with respect to x on both sides. I'm going to differentiate the left hand side, which is f of x, and then I'm going to differentiate the right hand side, this entire thing, cos of log of cot x. Now d by dx of f of x is f dash of x. D by dx of cos of log of cot x. I don't know how to do this, but then you can actually assume this complete thing as x in your mind. Assume that this is x. D by dx of cos x. You know that d by dx of cos x is nothing but minus sine x. d by dx of cos x is nothing but minus sine this thing. I assumed it as x. But then in reality this is not x, so I'm going to differentiate this as per the chain rule. So I'm going to differentiate this thing, log of cot x. Let's do it. F dash of x is equal to minus sine log of cot x d by dx of log of cot x. I don't know how to do this. Let us assume this thing as x. So in our mind I'm going to assume this as x, and you know that d by dx of log x is 1 by x, isn't it? D by dx of log x is 1 by x. D by dx of log, let us consider this complete thing as x. So d by dx of log x is 1 by x. But in reality this is not x, this is cot x. So as per chain rule you have to differentiate this thing as well. So what do we end up getting? F dash of x is equal to minus sine log of cot x into 1 by cot x into d by dx of cot x. What is d by dx of cot x? D by dx of cot x is nothing but minus cosecant square x. So let's write it. D by dx of cot x is minus cosecant square x. D by dx of cot x is minus cosecant square x. Now you can keep it this way, or if you want you can simplify it a little further here. These three things that you see here, they are in multiplication, so you can multiply the signs here. Minus into minus, that gives you a plus. You are left with sine log cot x into 1 by cot x can be written as cos x by sine x, because cot is cos by sine, and then cosecant square is reciprocal of sine, so I'm going to write cosecant square as 1 by sine square x. Now you can see for yourself this sine x and then this sine x, they cancel out, and eventually you are left with sine log cot x in the numerator, and then in the denominator you are left with sine x cos x. So that's the derivative of cos of log of cot x. Thank you for being with me till the very end of the video. I hope you now understand how to find out the derivative of a function. In the next video, perhaps I'll teach you how to find out the derivative of a function using the first principle of differentiation. I look forward to see you all in the next video. If you have any questions or concerns, please make sure you let me know in the comment section. And if you have not subscribed to the channel yet, I would suggest you to subscribe to the channel, because I will keep making videos. Obviously every single day I'm going to post a new video, so it is actually going to benefit you. So make sure you like the channel, subscribe it, and then if you find the videos helpful, I would suggest you to share the videos as well, because obviously your friends or acquaintances are also going to benefit from the video. Have a great day ahead. I'll see you in the next video. Until then, goodbye.